An evaporator fan can keep spinning while delivered airflow collapses. The fan curve did not change. The airside system did. A clean coil, a wet coil and a frosted coil each create a different resistance. The fan motor must move air through the fin pack, overcome the guard and housing losses, deliver air through the product zone and return it without short-circuiting. This fan selection supports heat transfer. It does not by itself prove refrigeration capacity. Treat the unit cooler as one system: fan curve, coil pressure drop, guard, housing, airthrow, return path, frost state and defrost logic. A free air airflow number cannot describe the installed result. Plot the selected fan curve against the clean, wet and maximum allowable frost system curves. Each intersection is a different operating point. Check required airflow, motor load and stability at every condition the evaporator is allowed to reach. Air must reach the most remote product zone and still find a low-resistance return path. Check for supply-to-return short-circuiting, blocked aisles, door infiltration and stagnant corners. Required throw and acceptable product velocity are project-specific. Do not buy by diameter alone. Confirm blade geometry, guard, mounting, running clearance, airflow direction, rotation, selected duty point and the motor matched to that assembly. The product image is a family reference. The exact model and curve still control the decision. Verify supply, frequency, phase, minimum ambient rating, moisture and condensation exposure, insulation and enclosure, bearing lubricant, thermal protection, wiring and rotation. Do not assume a standard room temperature motor is suitable inside a freezer. Every door event can add warm, moist air. Moisture freezes on the coil, airside pressure rises and delivered airflow can fall. Door traffic, sealing, refrigerant feed, drainage and defrost performance all influence the frost load. Fan operation during defrost is controller and evaporator specific. A sequence may include refrigeration stop or pump down, defrost, drip time, fan hold and restart by temperature, time or both. Copy the exact approved sequence. There is no universal fan delay time. A fan that will not run, a fan producing weak air and an evaporator with uneven frost need different evidence. Check the control request, safe supply test, protection and wiring, rotation, coil blockage, guard clearance, speed, current, refrigeration feed, door infiltration and defrost coverage. Map temperature and airflow with a clean coil, design product load, a representative door event, the allowed frost state, defrost and restart. Record current, speed, vibration and sound while confirming product zone uniformity. For a useful evaporator fan review, send the room set point, product load, coil data, required airflow and static pressure, supply and return path, voltage and frequency, mounting drawing, protection requirements and complete defrost sequence. Longwell can then review a real duty instead of guessing from fan diameter. Visit longwellfans.com/contact.